This week, we're going to look at two chapters, Chapter 6 and Chapter 7. And Chapter 6 is another one of those workflow chapters where you just go back and kind of reflect on what you've done and get a sense of, here's where you should be developing your skills. Here, these are some things that can really speed up your work. Chapter 6 is just kind of reflecting back on what we've done so far and to try to get us to consider some of the skills of the data scientist. First thing I'm going to do is to go bring up the Chapter 6 code file. I have downloaded that into my downloads folder, and now I'm going to start a new project, and we'll just call this one Chapter 7. Read the project. Okay, here it is. Nothing interesting happens here, but now all the files will be stored under that chapter folder grip. The first thing that you want to do is to go and find that folder. So go to your downloads if you downloaded it there. So we're going to open up a file, and this one may be one that you've 225 folder. And then here you can see what it's looking like, Chapter 6 code. It's an R script. So it's not going to be an R markdown file this time. Notice you don't have the YAML heading up here, and it's just kind of a header that I put in there. Everything that's in this file, everything that's in text, you just want to read, you put the little $sign in front. And then there are some common packages. I would encourage you to always run install your packages up front. Tidyverse, we tend to install it at the beginning of every project. If there's a case where you find a function's not working, it might be the case that you didn't install the packages that your code needs. And the nice thing about the R script is that once you put your cursor anywhere in, say, line 7 here and hit Control Return or Control Enter, it runs that command. So now you're installing Tidyverse. But in addition, after you run that line 7, it automatically jumps down to the next line of code. With the R script, you're going to use when you draw some plots, you're going to be using the plots window. And so I'm going to enlarge that at some other point. As you're working through the 4 panes, a lot of times you work just in this window or in this window. And sometimes you use this one. Every now and then you got to go here. Every now and then you have to go here. And it might be a good idea to just minimize those panes until you need them, and then bring them over, check them out, and then send them back. Now, for my presentation here, I am going to zoom. All right, so I want to improve the view. So I'm going to come in here to view, and I'm going to zoom in. So that makes it a large, maybe a couple of times there, and then I can bring this window back over to something that's a little reasonable. If you happen to enlarge this and the code goes off the off the screen like this, you could come up here for the code and just do the soft wrap on the long lines, and then it'll automatically scroll this back so you don't have to continue to adjust this window. All right, so now it's big enough. Since the cursor is on this line, I'm going to continue and just hit Control Return there, and notice it jumps down to the next line of code, and New York City flights are being installed, that packages. So then I'm just going to go through all these libraries. If we use the flights data, Tidyverse, we're going to load that library. ggplot is part of Tidyverse. I load it anyway. And dplyr, I want to make sure that that's loaded, and then Tibble are some that we use. Now, in this chapter, you might be using some new data sets, like there's one called Faithful. This is the old Faithful in Yellowstone Park over in Wyoming there. And they have that geyser that is very faithful. It erupts pretty regularly. And so you have just 2 lines of data here. I'll show it to you. Now, when you come up into global environments, you'll see something down here that says data sets. There's lots of data sets in there. So if I don't mention this before and you're looking for a data set we're using, it's probably in here. And so here's a listing of all the different data sets that we could possibly use. And Faithful is right here. And let's just do Control Enter to see that data. So you can see the data, you can see some sample code up in the environments window. You see, once you select, so once the package is there, and if you want to see it in a little bit more detail, just start typing the first few letters, and there it is. And if you want to see the variables, you can see just just those two there. If you want to know something about miles per hour, just want you to know that you can bring it up on the environments window to see some information about it. And you can bring it up here as well down in the output screen. You can see information on diamonds, on flights. And then when you get down to Superstore, now remember that this was not an R data set. This was one that I gave you that imported. So I'm going to go ahead and insert. I'm going to browse, and I think I'll go to the documents folder. Nope, I'll go to data sets, and then somewhere in here is the Superstore data set. Yep, that's the one. Import it. All right, so now it's in here, and so now I can click on down, and it can give us all the information on the variables. A data frame comes up in your source window, your content window, and there's a tab for that data if you ever want to see it. And then here's back to your code file. Okay, so here is a library help command, something that you can type in here. And if you do that, it'll give you information. It'll also say a little bit more information about all those data sets. Doesn't look like they're in alphabetical order. There's 2 chunks of them. But here's faithful, and it has the old faithful data. So that's documentation for the package, and you can do that anytime by using the help command inside the library function. Here's something good that you can do in when you're working with our code. You can assign a long file name like sales Superstore dataset 2. You can make an assignment statement and just say that data set is now X. So X is equal to. So everything that was sales Superstore dataset 2 is now X. So you can use either one interchangeably. You can also, where these functions are also very helpful. This is just an assignment statement, by the way. So when I do control enter, it doesn't do anything other than just assign that. But it does jump down to the next set of code. So when I do control enter, you'll see that you have the entire 9,984 records of this Superstore data. And here's the dimension command as well, 21 columns. And don't forget the head. That's just a quick way to list the first 6 rows of the data set. Chapter 7 is going to go back and go into a little bit more depth into the ggplot, and I'm going to put the ggplot package and the dplyr package together, all those functions that allowed us to manipulate the data. All of those are going to be together in chapter 7. Now, I think one of the messages that the author wants you to get out of this section is that, number one, that our script files are a very effective way to publish and experiment with your code. The other thing is that this particular file here, when you encounter as a data scientist, when you have a problem, you're going to want to bring in information about all the variables that will help you solve that problem from the data set. And so it's a good idea to have an intimate understanding of what the variables mean, their possible values, and how they may be related. As you develop skills in statistics and data science, you're going to be asking the questions. You're going to be looking at the data and posing the question that, I think this relationship exists. Let's go and run a piece of code to see if a relationship does exist. Some of these ways that you analyze the statistics with tables and graphs, you'll want to do frequently every time you get a new data set, particularly if you're not familiar with the data set. The next commands in this file take you through just some of the possible tables you can generate and graphs that you can generate to try to visualize what your data set looks like. Once you do this exploratory data analysis on all your variables, then you can start to see some relationships, and you can start to ask some questions and report some interesting findings. All right, so this one, just notice now instead of using Superstore sales here, and the thing about this file is that we could change sales Superstore data set. I could choose one of these other data sets like MPG and diamonds, and since we define it to be X, every time the data frame, as you're reading through these commands here, it's just going to be referring to the data set X as you defined it. So you can define it as the Superstore, you can define it as the diamonds, you can define X as the MPG or any data set you'd like. And so the first thing we're going to do is just go ahead and give a summary of the sales. Notice that the summary gives you the 5-number summary, min, first quartile, median, third quartile, and the max, and it also throws in the mean. We want to do the same with profit. I only put an additional one on here because whenever you have a variable name that has a space in it, you have to put the single quotes around the variable name. Otherwise, it's going to have a difficult time. It'll just think that you're calling up profit, the variable profit, and then there's a space and ratio, and it won't understand. So you got to have quotes around any variable name that has a space in it. Again, the 5-number summary using the same our function, the summary function. Just got to give the data set name followed by the $sign followed by the variable name. Then we can create some tables. Tables are very useful when we have qualitative data. So here is a listing of the different categories. Remember, we have furniture, office supplies, and technology sales in this data set. Now, if you have lots of different possible values, maybe a table is not the best way to go. And you can see down in the console, there's just all kinds of cities there. So they all have very, very small frequencies like 1 and 5, sometimes bigger cities will have more. Even Atlanta, big city, only has 39. And here's just another example of, if you want to create a table with a variable that has a dash in it or a space. In this case, if you just did subcategory with the dash, R might try to interpret that as a subtraction problem. So put quotes around that as well. And you can see the subcategories. There's lots of additional subcategories as well in addition to cities. So now let's take a look at a couple of graphs. And for this one, I will enlarge the plot screen a little bit more. And as I do that, you can see another way to just quickly do it is just to minimize the environments window, and then the graph window goes all the way up. So for categorical variables, the best graph to draw is a bar graph like you see here. You can see how the categories, the frequencies of the categories relate to one another. In this next graph, we are looking at the same exact thing. Notice that those bars are exactly the same. The only difference is that instead of putting the frequency scale on the vertical scale over here, we put the proportion scale. And in this next example, you'll notice that we're identifying the variable that we want to plot, but we're going to fill by the category. So we can see if there's a relationship between the ship mode and a particular category. So for example, our technology items may be more expensive. Are those more likely to be shipped using first class? All right, so this is a multiple bar graph, and you can see fill as category. So this one is going to involve colors. And here you can see the multiple bar graph. If I extend it horizontally, maybe it'll give me a better graph. You can see for first class, they all are about the same. They have many more sales that are for the office supplies. Those are going to be the green bars for any shipping mode. So it's hard to tell. And it always looks like furniture is a little bit higher than technology in each case. So it doesn't appear that there is a difference between shipping mode if you consider the different classes. All right, so here is another example of the three graphs that we just did. I'll enlarge the plot window. The difference is that in this case, we are looking at category. So there's the category instead of the shipping mode, just your basic frequencies here. And then you have the proportions here on the next one. The bar graph, however, is exactly the same. This is something you want to use if you're going to investigate a single set of qualitative data. And in the last one, you have a multiple bar graph where category is on the horizontal scale, and the legend this time is the ship mode. So as you might expect, they all go in proportion to one another, and office supplies are the most popular product that we sell. The next one is, we're just going through all the plots here. So we've got qualitative data, bar graphs are good. And so that's why we focused on the geom bar. All right, now we're going to get into numerical data. And if we want to look at the relationship between two numerical variables, a scatter plot is a very nice graph to use. And so here it is. And you're always looking for relationships here. So generally, if the sales increase, you might think that the profit increases over here. But that's not always the case. Sometimes when the sales increase, the profit is actually does not conform to that trend. And so it would be interesting to know, does the discount that a business gives to an individual customer, does that impact the profit? All right, in the next example, you'll notice that we're comparing a scatter plot again, but we're using two different variables, profit and profit ratio. And there it is. In the next graph, same thing. It's just we're going to jitter the points. When you look at this graph here, discount comes in kind of discrete values. There's a 10% and a 15% and a 20% and a 25%, but you're not going to see values like 23.7%. But the X is a discount, so we're going to see all these points lined up in a straight vertical row. When we do the jitter, it kind of jitters them a little bit left, some of the points a little bit left or a little bit right, so you can actually see the magnitude of the number of points that are on there. Okay, so the discount was the horizontal variable. You can see that, you have no discounts down here, very, very highly concentrated points. So there are many, many sales that give no discounts. And then you got the 20% discounts and the 40% discounts and so on. It appears that every discount is given for any possible quantity because the items are so different. All right, in this next one, another jitter graph, but this one's going to be discount on the vertical axis and profit on the horizontal axis. So there it is, but there's no missing this trend. You'll have all the points over here with these low discounts. All of these points are above the x-axis, meaning the profit is positive. So when you have a low discount, the profits are larger. But as soon as you start getting into the 40% discount range, almost all the profits are negative, which means this business is experiencing a loss every time they give a discount of 40% or more. Another way to display numerical data, particularly if you have just a single set of data, is with a histogram. So we're going to look at a histogram, and it just involves a single set of data. And so we're going to use category. So if you have this file created where you can change the data set, remember when you change a data set, you're also changing the variables. So you might have to come in here. A histogram is a completely inappropriate graph to do for a categorical variable. So what you want to do here is probably do a histogram on a numerical variable like profit, something like that. And then when you do the histogram, you can see it's not very interesting because most of the profits are near zero. All right, so if you want to do some other things like filter or anything like that, and you want to generate your visualizations, which you usually do, I would recommend from here on out using pipes, and it's particularly for the longer code segments. So our first one, here you can see it filters. We want all of the sales that are larger than 1,000, and we want to make a positive profit. We're going to print out, we're going to select the columns, the variable sales and profit and quantity, and that's what we're going to display. And then we're going to arrange those sales in descending order by sales. And so when you come down to the three columns are printed, and you can see the sales are in decreasing order. In the next one, we're going to look for profits that are more than 1,000. And so we're looking at big ticket items. And so quantity is less than 10. And then again, we're going to print the sales, the profit, and the quantity. But now we're going to arrange in descending order by quantity. This is something that you want to do if you want to identify the top 5. If you just create a table and it's in descending order, it will definitely print off those quantities in descending order. And there you can see it. Here's the quantities, and they're in descending order. And it looks like there's 41 different records of this sort, rows of this sort. In the next one, we're going to filter. We want all of those sales where the sales quantity or the sales value was over $5,000, and we sold less than 10 units. Now we're going to group by state. So when we group by state, state automatically becomes one of the columns in our display table. Then we select sales, profit, and quantity in the next row. And so we're going to have state, sales, profit, and quantity all listed in our table. And we're going to arrange those records in descending order by the profit dollars. So let's see what happens. All right, so when we enlarge the output, you can see that there are about 18 rows here. You've got the state plus those 3 other columns, and notice that they are listed in decreasing order by profit. One of the profits was even negative on this one, but those are the 18 different records. Okay, so again, we're trying to display some tables after filtering. and we're going to generate some graphs after filtering. All right, so this next table is one where we filter, we want profits that are larger than $1,000. We want fewer than 10 items. And now we're going to group by city. Now there's many more cities. And so we're going to have a much longer table here. Let me run this code. And as you can see, there it is, all the different cities. And there are 41 different cities listed where sales occurred. And they are being sorted in descending order by sales. All right, sometimes you just want to count the number of records. And so the number of records will be displayed on your table that you print out. But if you just want a quick function that just displays to the screen without the table, you can use the count function. X is our Superstore, then the pipe. We always declare the Superstore there. And then we're going to filter. We want all the sales. So we've got now this new data frame. Filter creates it. So this is the count function, and all it does is just count the number of sales greater than $1,000 that have a positive profit. So to the output screen, all you see there is the count. The data scientists really, when they use this code a lot of it, just the structure, these dplyr commands, filter, group by, select, arrange, these are going to be used a lot because you want to filter your data a lot. And you'll memorize the general structure. You know, for example, for the pipe, always the data set. You know, in this one right here, we could declare the data set as the data set with the filter already in place, but we have to declare the data set that we want to filter. So we put in X here with a comma, so filter, and all of these functions in group by and select and arrange and filter, all of them are from the dplyr package. And in the dplyr package, the first thing that we have to enter in is the data set in a filter command, except in a pipe. In a pipe, if we have X up here, then all of these are going to recall the same data set that we declare up here. So notice when I run this code, it's in the same format. It's in the format of, okay, here's my data set, and then group them, list the city, sales, profit, and quantity, and then descending order by sales. So the two tables give you the same thing, but you could declare your data frame up here as a filtered data frame from the original. All right, I prefer just to always just establish the data frame only up here, and then put the filter command inside. And just remember that you always have to have, for a pipe, you have to have the pipe symbol at the end of each row, except the very last one, and then run the code again, and there it is. Here's another similar one where we want to count the number of records where the sales are larger than 0 and the profit. I think we did that one before. And then here's the next one, 18 records we saw before where the profit was greater than $1,000 and the quantity was less than 10. And then we counted up the number and saw that was 41. And here are some filters that can create tables. And again, you're strongly encouraged to use these. In the first one, we have data and pipe. Notice pipe goes at the end of each row except the last one. You may find a situation where one row runs over into another line, but that's all one line, and then the pipe comes after it. It's okay. If I extended this out, you know, as long as I could, then the pipe would be at the end. But in situations where the line is too long, it'll just continue along the next row and will not cause a problem. So this is the one where we want only the Texas sales, only the first class sales, and the subcategory has to be paper. And because I want to create this table and filter by this way, I want to make sure that, you know, when I print this table out, that I have, you know, the state, the ship mode, and the subcategory all listed there so that I can see them. And I'm going to arrange these by decreasing quantity. You can see here that I sorted by paper, and every one of the records in here, it turns out to be that there are 25 records that were paper sales, that were first class shipping, and involved Texas. So you can see that this filter seems to be working. Notice that we're listing these records in descending order by quantity. This one is very similar, except now we're listing by decreasing sales. In this one, we're filtering only on first class, and we're still going to list all of these in our table and arrange by decreasing quantity. So you can see that states are different, and we have first class, and we're listing these by decreasing quantity. And again, listing by decreasing quantity is important because this is how you identify the top 10. All right, and then the last one, we're going to filter by subcategory is paper, so you can see when it does print it, and there are 1,360 sales. So this might be Dunder Mifflin, a lot of paper sales. Okay, so the data scientist is not a memorizer of code. A data scientist is a person who understands that we do have code that carry out certain things. And in the dplyr package, we know that the things that the package does is it manipulates our data. And we have filter, select, summarize, arrange, and group by. And all of those, when you use them individually, you have to have the data frame as the very first argument of the function. Unless you do the pipe and you declare your data frame at the beginning, then it's understood that everything inside this pipe will be referring to that data frame, and so you don't have to repeat it in the functions over and over and over again. But get used to, as a data scientist, of copying and pasting and trying something else out. So this one down here, I could arrange by sales and select that one, run it, and you got the same data, the same filter, except now the sales are sorted. So you will find that there are some things in here that in this programming that are very tedious. You'll be missing a space, or you'll use the wrong quote, or you'll filter the data, but then you'll ask it to print, but it's printing the original data set and not the filtered one. And the last thing that I'll mention here is that when you're doing coding, and you know that it's going to use a lot of these functions from dplyr, then you might want to just go to a file like this one, for example, and just copy the whole thing. So copy the whole thing, because it has down at the bottom, or as you go through the whole thing, it gives you all of these functions that we use a lot in ways that we analyze a data set. And so when you're working on another project, you can come up here and open a new file, a new R script, and come over here and just paste it in. And it's not, eventually you're going to delete it out because it's not part of this project. But then you can come up here and you can do your code. And if you notice that, if you know you're going to use a filter, then since there's so many uses of filters in this document, you can just come up here and say, how do I use filter to do this? And you can just scroll through your all of the instances where you used filter, and you can see if one of these makes sense. Unless you have a reference document that you cite over and over again, sometimes just pasting the code down here temporarily so that you have a resource site in your new document. So continue to work with these same commands. Pretty soon they're going to get simple for you. You're going to memorize them. You're going to know what's required, but also get good at copying and pasting and using code that you've already used. That's what the data scientist does a lot. And they get better at it over time. They memorize more things, but there's always going to be another piece of code that comes up that you're going to have to copy and adapt to your own situation.